Let's talk about these two probability problems. First off, we have 5 cards are dealt from a well-shuffled deck. What is the probability that all 5 are hearts? So the probability of 5 hearts. First off, we realize that this is essentially an AND question. It's the probability that the first one is a heart. And we need to have the second heart. And we need to have the third card to be a heart. And I'll continue writing this out. And the fourth one has to be a heart. And the fifth one has to be a heart. Okay, this is an AND question. For AND questions, we always multiply. So let's take this apart. Probably the first card as a heart is 13 over 52. There are 52 cards in the deck, of which 13 of them are hearts. Then I multiply by the probability that the second card is a heart, given that the first card is a heart. So the probability the second card is a heart, given that the first card is a heart. If the first card is a heart, there are 51 cards left. Of those 51 cards, 12 are hearts because I assume that the first card is a heart. Then I multiply again for this AND. The probability the third card is a heart, given that the first 2 are hearts. So the first 2 cards are hearts. That leaves 50 cards left, of which 11 are hearts. Then we have 49 cards that are left for the fourth card, of which 10 are hearts. And then finally, for the fifth card, 48 cards are left, of which 9 are hearts. Okay, so I've got a calculator next to me, so I'll do the arithmetic here. I have 13 divided by 52 plus 12 divided by 51 times 11 divided by 50 plus 10 divided by 49 plus 9 divided by times 9 divided by 48. And that gives me 0.0000495. And if you wish, this is not required, if you wish, you can take the reciprocal of the number that we just got. And I get an answer that's about 2019. So one chance in 2019. And when talking with non-scientific audiences, usually an expression like that is a little bit more palatable than 0.0000495. To say there's one chance in roughly 2000 is a little bit more palatable than writing 0.0000495. But that's the answer to part A here, or the first question. The chance of dealing 5 hearts in a row is about 1 in 2000. The second question, suppose we have a class of 50 students. What is the chance that at least 2 of them share a birthday? Okay, so the way that we're going to approach this problem is as follows. So the probability at least 2 share a birthday. Well, the opposite of that is that no one shares a birthday. So this is the opposite of that would be 1 minus the probability of no common birthday. All 50 people have different birthdays. And because those are complementary events, we can write the probability of at least 2 sharing a birthday is 1 minus the probability of the complement. All right, now the probability of no common birthday can be also found by multiplication. Let's take a look at person number 1. The first person in the room can have any birthday in the calendar, so 365 over 365, ignoring leap year. The second person in the room, there are still 365 possibilities. However, now only 364 are favorable. Okay. If I want the second person to not have the same birthday as the first person, the second person has 364 days to choose from, so to speak. For the third person, it'd be 365 in the bottom, and now there's 363 days for the third person to choose from, as long as it's not one of the first two people, and so on. So we keep multiplying until I get to the 50th person, so I have over 365. And this last person will turn out to be 316 over 365. The answer for the numerator here is not going to be 315. Notice that for 2 people, I subtracted 1 from 365. For 3 people, I subtracted 2 from 365. So for 50 people, I subtract 49 from 365. Okay, so the numbers multiplied together is the probability that nobody has the same birthday, and then 1 minus that will be the probability that at least 2 people share a birthday. Now, there's no shortcut to this except a little bit of elbow grease, so let's do this. 365, and then we'll take 1 minus that number until I get all the way down to 316, the 50th person on the list. Okay, so let's figure out all those fractions. So equals A1 over 365. So there's all those numbers. And so I need to take the 1 minus the product of those 50 numbers. So I'll multiply those 50 numbers together and then take 1 minus the product, and we get an answer of 97%. So given 50 strangers, we're not some kind of convention where people all are born in January. Assuming we have 50 perfect strangers, or reasonably perfect strangers, where the birthdays are uniformly and independently distributed throughout the year, there's a 97% chance that at least 2 of those 50 people will have the same birthday.